You know that specific feeling of satisfaction when you finally clean out a junk drawer?
Oh, yeah, definitely.
I mean, that one drawer in the kitchen that you've been totally afraid to open for like 6 months.
The one with the dead battery.
Exactly. You pull everything out, and you realize you have, I don't know, 5 broken charging cables and a menu for a pizza place that closed in 2019,
Right.
and you just purge it.
It's a very specific type of dopamine hit. It really is.
Yeah.
It's this realization that you have been carrying mental overhead for things that serve absolutely no purpose.
Right.
You clear the clutter and suddenly the room just feels bigger.
Exactly. And today, we're applying that exact same spring cleaning energy to something much more abstract, but honestly, just as messy.
Code logic.
Code logic. We're doing a deep dive into a really fascinating blog post from a site called keonmeng.org. It's dated February 21, 2026. And the title is a bit of a mouthful, actually. It's called Notes on Haskell Programming Part 64, Exploring View Patterns and LambdaCase for Cleaner Logic.
Part 64. That number alone kind of stops you in your tracks.
It really does. I mean, it tells me immediately that this isn't some, top 10 coding tricks listicle generated by a bot.
Right, exactly.
This is a chronicle. It's a deep, ongoing documentation of a journey. And the author, Ang, refers to himself as an old software plumber.
I love that title.
Me too. And that title, software plumber, it's really the lens for our entire conversation today.
Yeah.
It's not about being a rock star developer or a ninja or whatever buzzword is popular this week. It's about keeping the pipes clean and ensuring the flow moves.
Which is a really vital distinction in our field. I mean, in the world of software, plumbing usually refers to the invisible infrastructure.
Right.
The data pipelines, the validation logic, all the unglamorous stuff that connects point A to point B.
The stuff the user never sees.
Exactly. If the plumbing leaks, it doesn't matter how pretty the user interface is, the house is going to flood.
And today is all about fixing a very specific leak. Convoluted logic. We're going to track the author's journey as he tries to refactor a pretty messy piece of validation code. He starts with a clunky, wordy instruction set.
Then he experiments with a flashy feature called ViewPatterns.
Right. Realizes it's not quite right. And eventually he just stumbles onto a solution called LambdaCase that kind of changes how he thinks about data flow entirely.
It is a classic narrative of engineering discovery. But the real hook here for me is the tension he uncovers along the way.
Okay, tell me more about that.
Well, there's this constant battle in programming between writing code that is idiomatic,
Right.
which usually means concise, clever, and using the latest features,
Yeah.
and writing code that is accessible, meaning a junior developer can read it without having a total panic attack.
The battle between the cool and the clear.
Precisely. And often those two things are completely at war with each other.
Before we get into the syntax battles, though, we really have to talk about Ang, our old software plumber.
Yes.
Because looking at his blog sidebar, it's just, wow, this is not someone who just lives in the text editor all day.
No, he seems to be a polymath of the practical world.
I was scrolling through the tags here to get a sense of who we're learning from, right? Obviously, tons of Haskell.
Right.
But then, notes on fish keeping.
Yeah.
And we aren't talking, I fed the fish today.
No.
We're talking part 201, balancing algae growth.
Yeah.
Or relocating jewel cichlids. Beta spawn logs.
It points to a very specific personality type, doesn't it?
It really does.
Someone who is deeply empirical, whether
Yeah.
he's managing the pH balance of a fish tank or the type system of a compiled language, he's observing, he's tweaking variables, and he's documenting the results.
And the gardening. Notes on gardening part 814.
Wow.
800 parts. He's tracking red pineapples and rediscovering mealybugs.
Think about the patience that requires. Gardening and fish keeping are systems where you can't just force a result.
You can't just hit compile.
Right. You have to create the right conditions and let the system do the work. If you have an algae bloom, you don't just yell at the tank.
Right.
You adjust the light, you tweak the nutrients, you debug the ecosystem.
That is such a good way to put it. Debugging the ecosystem. It makes the coding advice feel much more grounded.
Yes.
This isn't some abstract theory from a university lecture hall. This is coming from a guy who understands that if you don't maintain the system...
Whether it's a tank or a code base.
Exactly. It just turns into a swamp.
And that brings us directly to the context of this post, part 64.
Right.
He picks up right where part 63 left off, which dealt with as patterns and record pattern matching.
Right.
He's in the middle of a project trying to build a generic argument validation function.
Okay, let's level set on argument validation for a second.
Right.
For you listening, In non-technical terms, this is basically the bouncer at the club, right?
That's a very fair analogy. You have data trying to get into your function. Maybe it's a file path or a username. The validation logic is the bouncer checking the ID.
Are you a valid path?
Do you exist?
Right.
If you let bad data in, your program crashes. So you need a strict bouncer.
But the problem Aang is having isn't that the bouncer isn't working. It's that the bouncer is taking forever to check the ID. The code is just, it's wordy.
It's verbose. In many languages, validation looks like what we call a staircase of doom.
A staircase of doom. I like that.
Check condition A. If true, then check condition B. If true, then check condition C.
Right.
If any of them fail, jump to an error message. Visually, the code starts indenting further and further to the right.
It just marches across the screen.
Exactly. It's hard to read, and it's hard to follow the logic flow.
So he wants to flatten the staircase. He wants to clean up the logic. And his first attempt involves a feature called ViewPatterns.
Right. This is where we get into the idiomatic side of Haskell. Haskell is known for pattern matching.
Okay.
Usually pattern matching is like looking at a shape. Is this a triangle? Do X. Is it a square? Do Y.
Simple enough.
ViewPatterns takes that a step further. It allows you to run a function on the object before you check the shape.
Wait,
Yes. So instead of just looking at the object, you can say, run this conversion function and then match against the result, all in a single line of code.
Okay, so using our bouncer analogy, normal pattern matching is looking at the ID card.
Right.
ViewPatterns is like scanning the ID card against a database and then looking at the result on the screen.
Close. It's more like the bouncer has a magical pair of glasses that transforms the person standing in line into their criminal record instantly.
Oh, wow.
You aren't matching the person, you're matching the result of the transformation. In the code, Aang is applying a function called inputPath to his data and immediately binding that result.
It sounds incredibly efficient. I mean, you're combining the action and the check into one step.
It is efficient, technically. It saves a few lines. But here is where the software plumber skepticism kicks in.
Right.
Aang tries it, looks at it, and goes,
Meh, after all that.
He calls it a minor syntax change. He says it's mostly syntactic sugar.
I love that term, syntactic sugar. It implies that the nutritional value, like the actual logic, is exactly the same.
Yes.
We just sprinkled some sugar on top to make it taste sweeter to the developer.
Exactly. It doesn't change the underlying performance or behavior. It just changes how it looks on the screen.
Right.
And Aang decides the sugar just isn't worth the calories. He points out a major downside. ViewPatterns is still considered an experimental language feature.
Ooh, experimental. In the world of software, that's usually a massive warning sign, isn't it?
It is.
Like buying a prototype car.
Right. Experimental often means you have to explicitly tell the compiler to allow it. It adds a dependency.
Right.
It means that if you hand this code to another developer who doesn't have that flag enabled, the code breaks.
Oh, that's annoying.
It's a custom fitting for your pipes that you can't buy at the generic hardware store.
Right. If I'm a plumber, I don't want to install a pipe that requires a wrench that was only manufactured for 3 months in 2026.
Exactly.
I want standard parts.
Precisely. He concludes that while ViewPatterns is clever, it doesn't offer a massive advantage for this specific validation problem.
It adds complexity without solving the core issue of flow.
Yes.
So ViewPatterns is a bust. He's about to move on. But then, and this is my absolute favorite part of the blog post, he says, while drafting this post, I've discovered a more significant refactoring.
The classic rubber duck effect.
Oh, explain that for you listening who maybe haven't heard that term.
The idea is that if a programmer gets stuck, they should explain their code line by line to a rubber duck sitting on their desk.
Right.
The act of forcing yourself to articulate the problem often reveals the solution.
It's so true.
Aang was writing his blog post, essentially talking to his audience, and explaining why the previous code was clunky. He saw the path to the real solution.
And what was the solution? What beat out the magical glasses of ViewPatterns?
A feature called LambdaCase.
LambdaCase. It sounds like a spy thriller. The LambdaCase.
It's less espionage, more calculus.
Fair enough.
But here is the critical difference right off the bat. Aang notes that in GHC 2024, that's the version of the compiler he's using.
Right.
The LambdaCase extension is enabled by default.
Enabled by default. That is music to the plumber's ears.
It means batteries included. It is now a standard part of the language. You don't need special flags.
It is the standard pipe fitting found in every aisle.
Exactly.
Okay, so it's standard. But what does it actually do that's better than the old if-then-else staircase? Or the do blocks he was trying to move away from?
To understand this, we really have to look at the shape of the code. The old way, if then else, is branching. If X, go left, else go right.
It splits the timeline.
Right. LambdaCase, combined with the bind operator, which looks like two arrows shoving data into an equal sign.
Okay, I can picture that.
That allows for linear flow.
Ang uses a specific analogy here that I really latched onto. He compares this new structure to a Unix pipe.
Yes. This is the key insight of the entire deep dive.
For the non-Linux users out there, paint the picture of a Unix pipe.
Imagine a literal pipe. You pour water, which is data, in one end. It flows through a filter. Then it flows through a heater. Then it flows out the tap.
Okay.
The water never has to decide, should I go left or right? It just flows through a series of transformations.
One direction, sequential.
Exactly. In the Unix command line, you might take a list of files, pipe it to a sorter, pipe that to a counter. Step A passes its result directly to step B.
So it's a straight line.
Yes. And Ang realized that by using LambdaCase, he could treat his validation logic the exact same way.
So instead of saying, check the path, if it is text, then do this. If it is not text, stop.
Right.
He is basically saying, take the path, shove it into the text checker, and handle whatever comes out.
Perfectly put. The code snippet he shares is tact path, then the bind arrows, then \case.
It's almost like an English sentence. Is text, in that case.
Yes, and it removes the need to create temporary variable names for absolutely everything.
Oh, that's a huge time saver.
It is. In the old if-then-else version, you often have to say, let result equal the check, if result is true.
Right. You're constantly naming things just to use them once.
Exactly. With LambdaCase, you don't need to name the result. You just catch it and handle it. It removes the verbosity. It flattens the logic.
Visually, the code stops looking like a jagged staircase and starts looking like a straight line down the page.
And for a plumber, a straight pipe is far less likely to clog than a pipe with 6 elbow joints.
That makes intuitive sense.
Yeah.
Linear is better. But I do have to play devil's advocate here. And Ang actually does this himself in the post.
The readability paradox.
Right, because if I'm a beginner, let's say I learned to code in Java or Python.
Okay.
I know what if-then-else looks like. I see the words if and else. It's English. I can read it.
Right.
If I look at this LambdaCase thing, the bind arrows and \case, that just looks like alien hieroglyphics.
It really does. And Ang explicitly acknowledges this. He says, quote, whether this improves readability depends on your familiarity with Haskell.
So is the cleaner code actually harder to read?
It's the difference between reading a paragraph of detailed instructions versus reading a mathematical formula or musical notation.
Oh, I like that comparison.
The paragraph is explicit. First, put your finger on the middle C key, then press down. That's if then else.
Anybody could follow that.
Right. The musical notation is just a dot on a line. It's incredibly concise, and if you know how to read music, it's much faster to process.
But if you don't,
It's meaningless.
so LambdaCase is the musical notation. It's the shorthand for the experts.
It is the idiomatic Haskell way. It's how the community agrees fluent speakers should talk.
Right.
But Ang is conflicted because he knows that the wordy version is more accessible to the learner persona.
The person who might be maintaining this code in 6 months and isn't a Haskell wizard.
Exactly.
This is the eternal struggle, isn't it? Do I write code that makes me look smart or code that makes my teammates' life easier?
Ideally, they should be the exact same thing. And this is where Ang lands on a fascinating verdict. He chooses LambdaCase, but not because it's cool.
Why does he choose it then?
Because it's batteries included.
Back to the standard parts idea.
Yes. He says, personally, my preference still leans towards language defaults. Since GHC 2024 made LambdaCase a default feature, it is no longer an experimental trick.
It is part of the standard grammar of the language.
Yes.
So the logic is, yes, this might be slightly harder for a total beginner to read initially,
Right.
but because it is the standard way the language works now, it is worth using because it simplifies the flow.
Exactly. He's betting that the Unix pipe flow, the straight line, is ultimately easier to maintain than the if-then-else staircase.
Provided you learn the basic grammar of the language.
Right. He's optimizing for the structure of the logic, not just the familiarity of the words. That implies stability and standard usage over niche features.
It's like switching from driving an automatic to a manual transmission. It's harder at first, but once you know how to shift gears, you have way more control over the car's flow.
And you aren't relying on a self-driving feature that might be discontinued next year.
Which was the ViewPatterns experimental feature?
Yes. LambdaCase is just the stick shift. It's standard.
I really appreciate that he arrived at this conclusion through trial and error. He didn't just wake up knowing the answer.
No, not at all.
He tried the experimental thing, he tried the wordy thing, and he found the middle ground.
It validates the struggle. Often when we read tech blogs, we just see the final, polished solution.
Here is the perfect way to do X.
Right. We don't see the 3 days of banging your head against the wall or the 4 bad drafts. Ang shows his work. He shows the dead ends.
I tried ViewPatterns. It was sugar. I didn't like it.
And that is incredibly valuable for a learner. Knowing why a solution was rejected is often more important than knowing the right answer.
It teaches you how to think, not just what to type.
It circles back to the fish tank, doesn't it?
It really does. You don't just magically have a perfect ecosystem. You try a new filter. Maybe it's too strong for the bed of fish.
But you swap it out.
Right. You try a new plant. It dies. You document it. Don't plant red pineapples in this soil.
A balanced aquarium is a self-sustaining system. It flows. Clean code is the exact same. It shouldn't require constant mental maintenance to understand.
It should just flow.
When Ang looks at that LambdaCase code, he sees a clean stream of water. When he looks at the if-then-else, he sees a beaver dam.
A beaver dam of logic. I love that.
Exactly. And his job as the plumber is to clear the dam.
So let's zoom out. We've been really deep in the Haskell weeds today.
We have.
For you listening who maybe writes in Python or JavaScript or doesn't write code at all but manages processes, what is the ultimate takeaway here?
The takeaway is the Unix pipe mindset. Ask yourself, is my process, whether it's a code function or a business workflow, branching into a million confusing if statements? Or does it flow?
Can I flatten the tree into a line?
Can you make step A flow naturally into step B? And secondly, are you using standard parts to do it?
Right. Are you relying on a weird custom Excel macro that only Bob in accounting knows how to fix?
Exactly. Or are you using the standard tools provided by the platform?
The batteries included philosophy.
It's the only way to build sustainable systems. If you over-engineer with experimental features, you are building technical debt.
And if you under-engineer with clunky, wordy logic,
you are building cognitive debt. It takes too much brain power to read it. The plumber finds the balance. Standard tools, clean flow.
I feel like I need to go look at my own workflows now.
Yep.
I definitely have some experimental features in my calendar management that need to be deprecated.
We all do. We all have that one view pattern in our life that we think is clever but is actually just making things complicated.
Before we wrap up, I want to leave you with a thought specifically about this idea of future you.
Oh, that's a good one.
Ang's whole journey here was about making the code better, not just for the computer, but for the human reading it.
Yes.
When you are doing your work this week, whether you're writing an email, documenting a process, coding a feature, ask yourself, will future me, 6 months from now, understand this?
Or will future you look at it and say, who wrote this? And why did they use so many acronyms?
Are you optimizing for the cool factor?
Mm-hmm.
You know, the jargon, the shorthand, the idiomatic way to sound smart. Or are you optimizing for clarity?
Because, as we learned from the software plumber, usually the standard linear boring pipe is the best one.
Boring is reliable. Reliable is good.
Definitely.
Ang signs off his posts with, "Till the next post." And considering he has thousands of them covering everything from Joule stitch lids to compiler updates, I'm sure the next one's coming soon.
I'm personally hoping for an update on the red pineapples.
I am fully invested now, too. Thanks for joining us on this deep dive into the mind of a software plumber. Keep your logic flowing, clear out those clunky if-then-else statements in your life, and we will catch you next time.
Till the next post.